Hi, this is Akhil Kadarla. Uh, I'm a graduate student in computer science department, and this is my first semester at ODU. Coming to my project is about predictive accident analysis and the causes for traffic violations. So this dataset consists of all the traffic violations in Montgomery County of Maryland District. So this is one data set which is official from the government website, and this data set is an 8 long calendar year data set which includes an aggregated amount of data on all law eligible traffic stops in the jurisdiction of Maryland. So the reason why I chose this project is to uh, after all the data insights and the data trends analyzing from this, we could use this data to increase awareness among the people and to encourage the DMVs to showcase people these trends so that they could understand how what are the reasons actually leading to accidents, and so that we could uh, employ safe driving practices and reduce the number of traffic accidents actually happening per year. So coming to the data set, this data set consists of around 1.04 million records, and these are all the columns which are available in the data set. So I'll just go over through few of the columns which are highly correlated to the accident target column, like the description which says is what is the reason of the specific charge, the reason for accidents like the bells, the alcohol, the personal injury, property damage. All these are Boolean variables, Boolean columns. So the main objective is to predict and analyze and extract essential information which is responsible for accidents made by the drivers. So my goal is to actually look at the facts on the statistics given by this data so that I could come into a conclusion that if it's the likelihood of a driver or is it the carelessness of a driver that is leading to this accident, and also to identify at what locations there are more number of accidents actually being recorded. So first things first, these are all my inputs: pandas data frame, numpy for calculations, and the sklearn for all the data machine learning algorithms. So this is the data set, and this is what the data looks like with all the 43 columns. So first, I've removed all the null values. So to check that, we could notice few of the columns have almost all the records null. So I've removed all those columns, and few of the columns have been dropped, which are not highly correlated and which doesn't explain my target column, which is accident, like the color of the car or the driver city or the sequence ID, which doesn't are used more in our data analysis. And after removing all those, and few of the columns like the year has junk data, like as you could see, there is 6,722 years, and this junk data is not useful and reduces the accuracy of our model. So all this data should be dropped. So after removing all the unwanted data, dropping all the unwanted columns, and dropping all the null values, we come with all the data types with zero null values, and also rename the columns to human readable proper naming conventions. So now you arrive at a proper data clean, which is actually required by your model. Now coming to the data pre-processing, first thing is that many of the columns, like I already told you, the seat belts, the alcohol, all these are Boolean data. And for statistical analysis, we need uh, numeric data. So convert that to bits, so one and zeros. And also the date and timestamps are in objects, as you could see from here. So I've converted them to date times, also extracting few of the essential information like at what month, at what hour, and what day the accident has actually happened, so that we could analyze the trends. And so this is a heat map which is plotted to identify which columns are or which features are highly correlated to accidents. We could see the personal injury and property damage are highly correlated. And coming to the time series graphs, this is a one time series graph for total accidents per day. As you can see, the upper control limit is around 35 accidents per day, and you could see that there are more accidents recorded in the year of 2017. So this is a total accident time series graph for month, and also this is in coincidence with the daily trends per day, and which shows that in the year of 2017 there are more accidents recorded, and this is the day at which the more accidents are recorded. As you can see, everything has same, and this is at what hour. So you could see at the evenings there are more number of accidents recorded, and these are the trends for violations. So we would just concentrate more on the accidents, and this is the sub agency at where more accidents are recorded. You can see the 4th district Waitan has more accidents, and these are the reasons for accidents. As you could see, failure to control vehicle speed is one of the main reason for accident. And so out of the whole data set, we have around 33K accidents recorded, which is not quite a few less, but even there are 33K lives have been affected. And these are the trends for violations. Are the how many citations have been recorded, how many warnings are there, and these are the type of vehicles involved in, and this is the gender. As you could see, more male. The accidents are more due to males, and these are the race. So coming to our main target column, so these are the trends for accidents that lead to fatal bells. As you could see in here, 2016, there are more number of accidents due to bells, and surprisingly, sorry, and surprisingly, there are many number of accidents recording due to alcohol. So, so coming to the accident analysis, let's jump to this. Okay, these are the fatal accidents recorded per month, which shows that in the month of September there are more number of accidents that lead to fatal. And so these are the citations which have been charged for the driver. As you can see by the ratio, we could say that uh, the alcohol citations have been is 9.43 times than the warning. So Maryland police are pretty strict on alcohol violations rather than all the others like personal injury, property damage, or work zone. And this is the count of the citations or warnings, and these are this is again the count for each violation type in the years from 2012 to 19. So these are the count of how many citations have been recorded for alcohol from bells. As you could see, there are few less citations, but for bells there is around 27K. So we could say, even though there are obvious presence of seat belt enforcement measures on the streets, we could say even 25K citations have been recorded. Like this might motivate local and state governments to put more resources toward this, or work with vehicle manufacturers to develop methods to reduce violations. So coming to the so our main objective to identify the likelihood of a driver. So we could see more of the road accidents are due to bells than alcohol, and most of the accidents has more property damage than personal injury. So they're misusing a lot of government property. And as you could see, most of the fatal reasons are due to accidents, which is obvious, and then due to bells. And surprisingly, this is zero with alcohol. And coming to the data modeling part, so for the data modeling, we first thing is to convert all the categorical data to numerical data for our data statistical analysis. So I've used label encoder to fit and transform it to my model creation. So I have used logistic regression and KNN, since this is categorical data like Boolean data and not continuous data. So this is my training and test data split. So as you could see, I have used label encoder to transform the data. And then first thing is uh, logistic regression. So I've used the logistic regression model to develop my traffic predictive analysis model. So which gave me an accuracy score of 97% for training data, and the the main F1 score of accuracy for test data is 96%. And for KNN classifier, I got an accuracy of for test data at around 96.8, 96.8%, which is almost similar to logistic regression. And with random forest, I got around 27%, which is very less. So since the target column in my variable is discrete, so logistic and KNN would be the best models to solve and predict, but not the random forest. So next is an prediction of location, like at what location more accidents has actually happened. So this gave me an percentage of around 41.8%. So as you could see from the test data at Old Georgetown Road, there are more accidents recorded. So this predicts the location at what place there are more number of accidents actually being recorded. So this is the total summary, giving an insight of what are the actual reasons for accident, the fatal reasons, and the damage caused by an accident, and the likelihood of a driver, which you could see bells have more, the fatal accidents per month. And these are all the trends which are used to analyze the accident trends. Thank you.